Well, hey there, kiddos. Here's your Topic 7 Functions and Relations Semester Exam Review video. We're going to talk about some things about functions and some things about relations, hopefully jog your memory. So we're going to fill in this table first. If you have been in Mrs. G's classroom, you have probably seen this hanging on the wall. It's been there pretty much all semester. So let's hope and see what we remember. We're going to fill in what we know. If the cause is the effect, then and the effect is dependent, then the cause is going to be, of course, independent. And so, of course, if we have x, then we have y. So x is independent, y is dependent. The domain goes with the range. Output goes with input. The follower goes with the leader. X again goes with f of x because f of x and y are the same thing. And the input goes with the output. So we had some repeaters there, but that's okay. So you get that all of these are the independent variables. They're the x values of whatever you're dealing, and all of these over here are the dependent variables and your y values of whatever you're dealing with. So the next few things we're going to rewrite showing dependency. So we're going to write it as a statement that says blah depends on blah, and then we're going to identify what the dependent and independent variables are. So an employee who works longer hours will receive a larger amount on her paycheck. And so as we think about this, what we're going to think about is that the paycheck depends on the hours worked. So to write just showing dependency, we're going to put the amount on her paycheck depends on, because this is how we show dependency, the hours worked. So my two variables are the things where it says they depend on. So it's the amount on the paycheck and the hours that get worked. Well, according to my statement, the amount on the paycheck depends on the hours worked. So the amount on the paycheck is the dependent variable because it depends on something to occur, and it depends on the hours that get worked. So the next one, a box with several books weighs more than a box with just a few books. And so the two things, my variables here are kind of hard to tell. My two variables are going to be the number of books and the weight of the box. And so to write it as dependency, I'm going to say the weight of a box depends on the number of books that are in it. And so according to that statement, the dependent variable is the thing that depends on is going to be the weight of the box. And so the independent variable of the thing that it depends on, and that will be the number of books. So let's read the third one. The student council is planning to raise money by selling Halloween ghost pops. They are not taking orders in advance but hope to sell 2,000 ghost pops. The cost to order ghost pops from Polly's Pops, wow, that's hard to say, is 10 cents each. And the student council will sell the pops for 50 cents each. So we've got to identify the independent and dependent variables. So the first thing we need to know is what are the variables? Well, the first thing that is going to be a variable is how much money they are going to make. The amount of money they're going to get is going to depend on how many of these ghost pops they sell. And so the dependent variable here is going to be the money, or their money raised, or their profit. And what is the independent variable is going to be how many ghost pops they sell. So now the next couple of problems, they just give you an equation and they want the independent and dependent variable. It is very easy whenever you have it written as an equation because the variable all by itself will always be the dependent variable, because in order to find out what this variable is, I have to know what all of these are. So the thing that's by itself is dependent. So the dependent variable here is v. And the independent variable up here, now it looks like I've got two variables, this pi and this r cubed, but pi is not a variable. Y'all all know that there's a number associated with it. It's 3.14, and there's a whole lot that comes after that, but there's a number that goes with pi. We just use a symbol to represent it. R cubed, the cubed's not part of the variable, just the r, so the independent variable would be the r. So on number 5, try it real quick. See if you can identify the dependent and the independent. Well, the dependent variable will be the thing that's all by itself, so y will be dependent, and then in this equation, the x will be independent. So my next few problems, I just have to state if it's a function or not. There are a couple of ways to determine if something's a function. First of all, to be a function, none of the x values can repeat. You cannot have any x values be the same if something is a function. You can also do this thing called the vertical line test, where you take a pencil, or in this case an actual line, and you take this vertical line and you just drag it across your graph. A pencil works perfect because you don't have this nifty little tool I have, but I have this vertical line, and if I take this vertical line and move it across this graph here, and the graph is this little curvy thing, not the XY axis. This graph is the curvy thing, and if I take this vertical line and drag it across where this curve is, if it ever touches this curve more than once, then it's not a function. And so if I take my vertical line here, right off the bat, it crosses it up here and up here, so my vertical line passes through that curve 2 times. That's more than once. And if I move my line some more, it's still touching it twice, still touching it twice, still touching it twice. So because it touches it in more than one place, that means I have x values that repeat. And so that means that this is not a function. So I can do the same thing with this other graph. I can take my vertical line here and I can put it on the points. Well, there is only one point that vertical line is on, so we're good so far. Now I have only 1 point, 1 point, 1 point. There's only one. There's only one, and there's only one. Since never, when I'm moving this back and forth, is there more than 1 point on the line at a time, then I get to say that this one is a function. So this is, yes, it is a function. So number 7, I don't need the vertical line. I'm just going to look at the x values. Are any of them the same? I've got -2, 0, -2 again. Oh, look, this x and this x are the same, which makes this not a function. So look at number 8. We're going to look at the x values. I've got a 0, a 0. Oh, look, they're the same. X values that match, not a function. Anytime you have x values that are the same, it's not a function. So number 9 here is about evaluating. They want us to evaluate f of x, which remember is the same thing as y, when it equals 4x minus 3 whenever the domain is -1, 0, and 2. If you'll remember, domain is the x value, so they're saying x is these 3 numbers. So I'm going to take this equation and 3 different times I'm going to plug in these values for x. So the first time I'm going to plug in -1. So I'm going to do 4 times -1 minus 3. I'm just find out what it equals. 4 times -1 is -4. Minus 3 is -7. There's the first answer. Next time I'm going to plug in a 0. I'm going to do the same thing. 4 times 0 is 0. Minus 3 is -3. There's my second answer. Then I'm going to plug in the 2. And 4 times 2 is 8, minus 3 happens to be 5. So my 3 solutions are -7, -3, and 5. Now number 10 here, these are probably the easiest way to answer questions about functions is if you're given a graph. You just have to remember what everything means. So we're going to use this graph to answer these questions. A says, what's the value of f of 8? If you'll remember, f of x is our function notation, and in f of 8 here I've replaced the x with an 8. So I want to know where x equals 8. So I'm going to look at my graph over here. This is the x-axis. It's marked for me. X equals 8 right here. And where x equals 8 on the little line that is drawn on here, then f of x, or f of 8, is equal to 0. Because that's the y value at that point. Now B says for what value or values, which tells me I could have more than one answer, does f of x equal 4? So now they are saying f of x equals 4, which is the same thing as saying y equals 4. Well, y equals 4 right here, and I've got to go across my graph and see how many times y equals 4. Well, y equals 4 right here and right here. So I'm going to have 2 answers. This one, when y equals 4, x equals 4. So one of the answers is x equals 4. Right here, when this is y equals 4 right here, then x equals 12. So my other answer is x equals 12. Now, question C says, for what values of x is f of x greater than or equal to 10? Well, so I'm going to change colors here so we can look at it. They want to know when y is greater than or equal to 10. Well, y equals 10 right here. This is 10. So I'm going to draw a line across here. And I'm looking for every place that it is greater than or equal to that at that line. Well, greater than that line will be everything up here. Equal to that line is this point right here, and it ends at this point, and every point in between counts. So this x value, if I come down here, is going to be 15, because it's going to be right before 16. So it starts at 15, and it ends at 26, because this counts by, my bad. This counts by twos. 4, 6, 8, 10, 12. You don't see them all, but it counts by twos. So this goes from 15 to 26. So for what values of x is it greater than that? Well, it's every value in between them, and we practiced this when we wrote compound inequalities. X is every number between 15 and 26. You could also say between 15 and 26. But that's the values that it is equal to it. So number 11, if g of x is equal to x squared minus 3x plus 2, then we got to find g of negative 2. Well, they've replaced my x with a negative 2. So right here, I'm going to replace with the negative 2. Since this negative 2 was not originally a part of this equation, when I plug it in for x, I'm going to put parentheses around it. So I'm going to do negative 2 squared minus 3 times negative 2 plus 2. Well, negative 2 squared means negative 2 times negative 2, and that's 4. I'm going to treat this like a negative. So negative 3 times negative 2 makes positive 6, and then my plus 2. So 4 plus 6 is 10, plus 2 makes 12. There's your answer. Now, number 12 and 13 are a little harder. We have to evaluate the function f of x equals 5x minus 3 for 2 times f of 3. This problem means I'm going to start with what's inside the brackets and do that first. Then I'm going to multiply everything by 2. So I'm going to plug in a 3 for x because that's what's inside the bracket. So I'm going to do 5 times 3 minus 3. And when I'm done, I'm going to multiply it all by 2. Well, inside first, because that's what we do. We do parentheses first. So I have 2 times. 5 times 3 is 15 minus 3. Well, 15 minus 3 is 12. And 2 times 12 is 24. So there is your solution. So number 13 is the same. It's the same kind of question, just a different function. Now I have 3x plus 2, and I want to find 3 times f of 2. Well, that means x equals 2. So I'm going to do 3 times 2 plus 2. And at the end, I've got to multiply it all by 3 because that's what's on the outside. Work from the inside out. 3 times 2 is 6. Plus 2, well, 6 plus 2 is 8, and 3 times 8 makes 24. It's just a coincidence that they have the same answer, but that's how you do those problems. You work from the inside out, okay? So there is your practice for topic 7. Hopefully it helps you get ready for your exam.